students, welcome back to our channel. So in previous session we have seen how to create a circular linked list and how to display the nodes of a circular linked list. In today's session we'll go with and also we have seen the insertion. So how to insert an element at the beginning position, at the ending position and at the specified position. So in today's session we'll go with another operation, that is deletion operation. So how to delete an element from the circular linked list from the beginning position and from the ending position and from the specified position. All the three cases we will cover in today's session. Right. Let us start the session. Right. Circular linked list. Let us take an example and we will start the session. So let us take a 4 elements, that is 4 nodes. Right. So we know that every node is having 2 fields, one is data, another one is the pointer field. So let it be 10, 20, 30 and a 40. The address of 10 is 1000, address of 20 is 2000, address of 30 is 3000, address of 40 is 4000. So the first node will holds the address of the second node, that is 2000. The second node will holds the address of third node, that is 3000. Third node will holds the address of fourth node, that is 4000. And it is a circular linked list. The last node holds the address of the first node, that means 1000. So there will be a link from last node to first node, right? And we know that the first node will be head and the last node will be tail, right? So we have discussed this deletion operation in the single linked list, that here deletion means just we are disconnecting the link between one node and another node. And if you want to deallocate the memory, we can use the free function. So that particular node, if you apply this particular node to the free function, automatically the memory will be deallocated. Okay. So first thing, we have to disconnect the link. How to disconnect the link? We have seen that just remove the address which is presented in the address field and replace with the null, so that automatically the link will be disconnected. Right. We'll go with the first case. So we are seeing this deletion operation. Right. So first one, deleting the element from the beginning position. That means if you want to delete a 10, so 10 should be deleted. 10 should be deleted. See. So I am drawing the output so that we will write the steps. So 10, 20, 30, 40, 3000, 4000, 1000. Right. So if you delete this element, the head must be moved to 20 and the address of the last node, the address field of the last node should contain the address of second one. Right. Now let us check it out. Head and tail. Right. So we should not change the head. So first I will give assignment to temporary variable, right? I will just give a head to temporary variable. I am now moving the head from first position to next position, because the head should be in the next position, because we are deleting the first element. So head is equal to head of next. So automatically after executing the statement, the head will be moved from here to here, right? Okay, then see this tail, I mean the address field of tail should map with the address of the first element. Here the first element address is 2000. So tail of next, so what is the tail of next? This field is equal to head. So after executing this statement, tail of next, this will be replaced with 2000. So here also the connection is disconnected, and here the connection is established. Now one more thing we have to do. What is that? This link should be disconnected. This link should be disconnected. So we have assigned head to temp. So here there will be temp. Simply we can write temp of next. Temp of next is equal to null. So automatically here it removes the 2000 and it places the null. That implies it disconnects the link between this node to the next node, right? So the output is this one. First element is 20, 30, 40, and the 40 is mapping with the first element. So hope you understood. So if you want to deallocate the memory, automatically if you apply the free function to the temp, automatically this memory will be deallocated, right? So hope you understood this. So first we are changing the head, and then we are establishing the link, right? Head is equal to head, we are establishing the link from tail to head, and then we are placing the null to the first node. That means we are disconnecting the first node, right? So this is all about the deletion of an element from the beginning position, right? Hope you understood. Now we will go with the second thing, that is deletion from the ending. Deletion from the ending. Yeah. See, here there is a link from here. It is 1000. It's not a 2000. It's 1000. Right. Now, second, deletion from end. Deleting an element from end. So here we have to delete the node 40, so that we have to move the tail to the left side, and 30 will be the last element, and the last element address should be the head, should be assigned to head. Okay, right. Now let us see. So just we will assign head to temp. We will assign head to temp. So automatically temp. Okay, we need to move the temp till 30. We need to move the temp till 30. So that means simply we can write the iterative statement while temp of next not equal to tail. So it will move until the temp of next not equal to tail. Right? So temp of next not equal to tail. So tail is 4000. Temp of next means 2000, right? So every iteration we have to move the temp. So moving the temp means simply temp is equal to temp of next, right? Let us test this one. First, temp of next 2000 not equal to tail 4000. True. So temp is equal to temp of next. Now temp of next means, so after the first iteration the temp will be moving towards this one. So here it is temp. Now temp of next 3000 not equal to 4000. True. Temp is equal to temp of next. The temp will be moved from here to here. Right? Next, 4000 not equal to 4000. False. So it comes out from the loop. Okay, it comes out from the loop. So after completion of these iterations, the temp is pointing towards the last but one element. Okay, so hope you understood this one. Now see what we have to do. Here we have to disconnect this one, right? We have to disconnect this tail. So simply replace this 1000 with null. So what is this position? Tail of next is equal to null. So automatically this 1000 will be removed and null will be assigned here. That means connection is disconnected here. Connection is disconnected. Then now what we have to do? Here we have to disconnect this connection between the last but one element and the last element, and also here instead of 4000 we have to place 2000, right? For that we know that what is this position? Temp of next. Temp of next means 4000 is equal to head. Temp of next is equal to head. Automatically here it will remove the 4000 and it will place 1000. So it was disconnected. It was disconnected here, and a connection is established from here to here. Right? Now tail is equal to temp because the last statement will be tail. So here we are assigning tail here. Just remove here. We can remove that one. Okay. So this is a small thing. Hope you understood. So how to delete an element at the ending position. How to delete an element from the ending position. So for here also, first we have to travel the temp from first element to last but one element. So there we have to disconnect the last element, right? So there is a link between the last element and the first element because it is a circular linked list. So first we have to disconnect the last element, that link between the last element and the first element, and then we have to disconnect the link between the last but one element to the last element, and we have to move the tail, right? So this is a small code logic for deletion at the end position. Right. Now we will go with the third one, that is how to delete an element from the specified position. Right, this is the third case. So how to delete an element from the specified position. So here we have to take the input as a position. So from where we have to delete the element. So The first statement is scanf %d ampersand position. So first we have to find the position where we want to delete the element. So then we have to move the temporary value, because we are not moving the head, so just will assign the head to temp value, right? So now we have to change the head position or a temp position from starting point to the position -1. So this is a code which we have seen in the single linked list. Simply do the iterations. I is equal to 0, I less than position -1, I plus plus. So simply we have to move that one. So temp is equal to temp of next. So here see, so initially this is the temp, because here we are assigning temp is equal to head. Let it be position is equal to 2. Position is equal to 2. So in the first iteration, I is equal to 0, position, sorry, I is less than position -1, 2 minus 1, 1. So true. Automatically we have to change the temp value. So temp is equal to temp of next. So 2000. So this temp will be moved to 2000. Hope you understood this one, right? So temp is equal to 2000. Now the second iteration, I plus plus. So I is equal to 1. So 1 less than 1, false. So just stop the iterations. Just to stop the iterations. What we have to do here? So we have to disconnect the second element. That means this element. So this element should be disconnected. So we have to disconnect the link between temp and the next value. So here, what we have done in the single linked list, just we are placing the address of, sorry, it is not null. Just we are placing the address of the next element. We are just skipping the middle element, the positioned element. We are skipping the positioned element, right? So we are just disconnecting the link, right? So temp of next is equal to, that means this position, temp of next of next. So temp of next means, see, 3000, and temp of next, that means 4000. So 3000 will be moved with 4000. Automatically this link is disconnected, and see, it is placing here itself. Okay, it is placing here itself, right? So hope you understood this one. So just we are placing the link, we are just skipping the link. Okay, so temp of next means this position is equal to temp of next, that means 3000 of next. So that means 4000. So 4000 will be moved in the address position of temp. Automatically that particular 3000 element will be disconnected from the linked list. Okay, so hope you understood this one, right? Right. So a simple thing. So there is no change in deletion of an element from the specified position. So the same code which we have used in the single linked list, the same thing we are using. So there is a slight difference in beginning position, deletion of an element from beginning position and ending position. Right. So let us stop here. So hope you understood my session. If you really understood my session, like my sessions, share my sessions with your friends, and if you are having any doubts regarding this session, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And don't forget to subscribe to our channel. Keep following our channel. Thanks for watching. Thank you very much.